Hi everyone, my name is Rachel Ryan. I'm a third year chemistry student and my URA STAR project is about modeling the oxidation of ethylene and studying how different metal atoms added to the reaction can mediate it or lower the energy barrier. On the left you see the ethylene with the gray carbons and the red oxygen forming ethylene oxide. We're interested in this reaction because ethylene oxide is a useful intermediate to synthesize different products, primarily ethylene glycol, which is used to make antifreeze. This oxidation normally occurs at high temperature and pressure conditions, and this is consistent with the spin state change from a triplet to singlet in the reaction. We're looking for a cheap catalyst that can lower the energy barrier and/or allow for a reaction to occur with no spin state change. A spin state change occurs when the number of unpaired electrons changes. This is a very unlikely process, thus if a metal atom allows for no spin state change, the reaction proceeds easier, even if the overall energy barrier is higher. The software we use to get our results is NWChem, but we also use Chemcraft to visualize our molecules. We ensure our values are accurate by comparing our calculated dissociation energies to known experimental values. We started off by finding the energy barrier for the oxidation of ethylene. We did this by 1, pushing the reactants closer together, and then 2, pulling oxygen and the ethylene oxide away. At a certain distance, the two energies intersect, which is approximately the point where the pi bond in ethylene breaks and the CO bond forms. This intersection occurs around 2 Armstrongs, which you can see on the left graph. This allows us to calculate the energy barrier, which is 0.205 electron volts. We then moved on to adding boron to the reaction. We attached boron to the ethylene, then attached oxygen, and looked for any energy barriers that were forming. If there's no barrier, then no energy is needed for the atom to attach. If there are barriers, then we compare the energy values to our ethylene oxide formation barrier. The only barrier we found was when oxygen attached to the boron-ethylene intermediate. It was around 0.36 electron volts. This is higher than the barrier for ethylene and oxygen, which is around 0.205 electron volts. However, the reaction in the presence of boron occurs without the change of spin state, which makes it more likely to occur. We checked boron attachment to ethylene and the detachment from ethylene oxide. The attachment to ethylene is barrierless, and the detachment has a barrier that requires energy around 0.33 electron volts. We attempted to do similar things with sodium, but the atom was always repelled from ethylene and ethylene oxide, meaning it would not be participating in the reaction. So in conclusion, sodium does not catalyze this reaction, and boron leads to a higher energy barrier but no change in spin state. Currently, we're experimenting with aluminum to see if we can improve our results further, and we went with aluminum because it is analogous to boron, and due to its larger size, it might detach more easily. This is where our future work will continue from. Thank you very much for watching.